Now in partial differentiation, let us see some simple problems because these are only basics. First problem, if z equal to f of x plus ct plus phi of x minus ct, prove that dou square z by dou t square is equal to c square into dou square z by dou x square. Solution. Actually, in the next semester you will get this equation is one-dimensional wave equation. This equation is called one-dimensional wave equation. And this is solution of wave equation. Okay, this is application. And let us see first, what is a function z? Z is a function of x comma y. Here in place of y, what is another variable? T. Z is a function of x and t. Okay, let me write here. Z is function of xt. Okay, so first see what I have to prove. Double derivative dou square z by dou t square, and the next one I have to calculate dou square z by dou x square. So let me find first order partial derivatives. And what is the first order partial derivative? First one, dou z by dou t. Let me find. Dou z by dou t means what? Differentiating equation 1 with respect to t. So first function derivative f dash x plus ct, and this x plus ct derivative with respect to t, that is c. See, remember in partial differentiation, if I take differentiation with respect to t means take x as the constant. Okay, same logic. Phi function derivative phi dash of x minus ct, and x minus ct derivative with respect to t, that is minus c. Now one more, dou square z by dou t square means what? Dou by dou t of dou z by dou t. That means for this above equation, one more differentiation with respect to t. What is that? See, this is again c is the constant. I can write f double dash x plus ct. C is already there, and again one more derivative with respect to t means one more c exists, and this is okay. Let me take plus phi double dash of x minus ct. Again x minus ct, already minus c is there, and for x minus ct derivative again one more c we will get. So finally c square is common. I'm getting what? F double dash of x plus ct plus phi double dash of x minus ct. This is the value of dou square z by dou t square, equation 2. Now dou z by dou x, then dou square z by dou x square. First one, dou z by dou x. First f derivative f dash of x plus ct, and x plus ct derivative with respect to x, that is 1, plus phi dash of x minus ct with respect to x, 1, and one more differentiation with respect to x. This is f double derivative x plus ct. This is 1 and 1 plus phi double derivative x minus ct. This is 1 into 1. So what is this expression? F double dash of x plus ct plus phi double dash of x minus ct. And let us substitute this value. This is the value of dou square z by dou x square, equation 3. Substitute 3 in 1, that is on RHS. Simply on RHS, that is in place of this. I have to substitute what? Dou square z by dou x square. That is the given result. Then dou square z by dou t square equal to c square into dou square z by dou x square. Okay, this is one simple problem. And let me take another one where I have to separate the operator. What is the question in here? If u equal to log of x cube plus y cube plus z cube minus 3xyz minus 3xyz. Show that dou by dou x plus dou by dou y plus dou by dou z whole square of u equal to minus 9 by x plus y plus z x plus y plus z whole square x plus y plus z whole square. See what is here? This is dou by dou z plus dou by dou y plus dou by dou z whole square. Remember, uh, this dou square by dou x square means what? Dou by dou x of dou by dou x. For example, if we get z, then z. Dou square z by dou x square means what? For dou by dou z, one more differentiation with respect to x. Now, dou square z by dou x square, this is not equal to dou z by dou x whole square. Remember this one. Here, whole square is there. So, it is not double derivative. For this one, I have to take whole square. Okay. Now, so first one, what is u function? U is given as log of x cube plus y cube plus z cube minus 3xyz. Then first one, let me calculate without whole square. Let me calculate this one entire. Without whole square means what? Dou u by dou x, dou u by dou y plus dou u by dou z. So let me calculate those first. First dou u by dou x. Logarithm derivative, 1 over x cube plus y cube plus z cube minus 3xyz, and x cube derivative is what? 3x square. X cube derivative is what? With respect to x, 3x square. Similarly, dou u by dou y becomes what? 3y square over x cube plus y cube plus z cube minus 3xyz. Next one. Dou u by dou z is what? 3z square by x cube plus y cube plus z cube.
Sir, in numerator, minus 3x.
Yeah. Minus 3xyz is there now. So minus 3yz is here. With respect to y, 3xz is here. And with respect to z, 3xy is here. Very good, right? These are the derivatives, first order partial derivatives. Now let us add all these. That means dou u by dou x, dou u by dou y, dou u by dou z equal to this. I can write 3 common in the numerator because denominator is same. That is next 3 xy minus 3 yz minus 3 xz whole by x cube plus y cube plus z cube minus 3xyz. 3xyz. Now 3 is common. X square plus y square plus z square minus xy minus yz minus zx by, the formula of a cube plus b cube plus c cube minus 3abc. What is that formula? A plus b plus c, that means x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Right? This is the formula of this one, a cube plus b cube plus c cube minus 3abc formula. So these two are getting cancelled. So what I'm getting, dou u by dou x, dou u by dou y, dou u by dou z equal to 3 upon x plus y plus z. 3 upon x plus y plus z. Now see, I can write this one as dou by dou x plus dou by dou y plus dou by dou z of u, right? It is exactly equivalent to dou by dou x is operated on u, dou by dou y is operated on u, dou by dou z is operated on u. Nothing but dou u by dou x, dou u by dou y plus dou u by dou z. So this value is 3 over x plus y plus z. 3 over x plus y plus z. Okay. What is the benefit of writing this? Because I have to calculate this dou by dou x, dou by dou y, dou by dou z whole square of u. Whole square of u. That means dou by dou x plus dou by dou y plus dou by dou z multiplied by what? Again dou by dou x plus dou by dou y plus dou by dou z into u, right? This whole square can be written as product of these two. But I know this value, this one, dou by dou x plus dou by dou y plus dou by dou z of u is what? This is equal to dou by dou x. This is now operator. This part is only first. This one is operator, partial differential operator. Operator means involving derivatives. Okay, and this value is what? 3 over x plus y plus z. Now assign individually. That means dou by dou x of what? 3 by x plus y plus z. Dou by dou y of what? 3 by x plus y plus z. And dou by dou z of 3 by x plus y plus z. Okay, now what is the derivative of this? This is minus 3 by x plus y plus z whole square and x derivative 1. Same logic here also, x plus y plus z whole square, x plus y plus z whole square, partial derivatives. Okay, so this is finally what is the answer? Minus 9 by x plus y plus z whole square is the answer. Whole square is the answer. And next one, let me explain one problem in change of variables here. Right, see. If u is the function of r, if u equal to f of r and x equal to r cos theta, y equal to r sin theta, polar coordinates, y equal to r sin theta, prove that dou square u by dou x square plus dou square u by dou y square equal to f double dash r plus 1 by r into f dash r. 1 by r into f dash r. Better, let me tell you, this is after change of variables. That's better, no? Okay, let me complete this. Doesn't matter. Solution. See here, before going to this, I need change of variables. Okay, let me tell you this problem after change of variables. Okay, afterwards. Now, the next one is total differential. Total derivative is the topic. Before that, I need this one, total differential. What is the definition of total differential? If z is function of x comma y, if z equal to f of x is a function of two variables, then dz. What is this? dz. That means change in z, rate of change in z. That's it. This is equal to dou f by dou x dx plus dou f by dou y dy. Dou f by dou x dx. See, derivative of z with respect to not anything, right? Dz means derivative of z, not with respect to x, not with respect to y. That is called total differential. Total differential denoted by dz. And for function of two variables, how it is defined? Since f is a function of two variables, first f derivative with respect to x, that is dou f by dou x into dx. X for x total derivative. Similarly, f derivative with respect to y, dou f by dou y, and for y total derivative, that is dy, is called, this one is called total differential. Is called total differential. And the next one is total derivative. Total, and okay, let me write one more for function of three variables also. If you write u equal to function of x, y, z for function of three variables is a function of three variables, then what is now in place of z? U is here, so du equal to I can write this as first f derivative with respect to x and x total derivative dx, f derivative with respect to y, it's a total differential dy, and f also function of z and it's a total differential dz. This is for function of three variables. You can extend for n variables also. You can extend for n variables also. Now total differentiation. Differential, now you can write total derivative. Simply you can write total derivative. See the change. If z is function of, z is f of xy is function of two variables, then total derivative of z with respect to x, see, underline this, with respect to x is dz by dx, equal to first f is function of see, I can write, yeah, dou f by dou x into what is this, actually dz means what, dz already we know dz value, now divided by dx throughout this one, then what is this, dx by dx, you will get here dou f by dou y into dy by dx, that means what, this is equal to dz by dx equal to dou f by dou x plus dou f by dou y into dy by dx. Okay, anyway, you must remember this, is important for function of two variables. Similarly, if let me write y again, I will write, if similarly for u equal to f of xyz, and sorry, for with respect to y also I can write similarly, total derivative of z with respect to y is, this is dz by dy equal to dou f by dou x dx by dy plus dou f by dou y, f is function of two variables, so partial here, and what is this, dy by dy. Okay, these are total derivatives with respect to x and y. Similarly, for u equal to function of xyz, if f, that means u is a function of three variables. First, what is the first total derivative? I can write, just 1 minute. Total differentiation. Yeah, I can write for the first one, for total derivative of u with respect to x, is dou f by dou x into dx, actually dx is there, and divided by dx plus next partial derivative of f with respect to y and into dy by dx, next f derivative with respect to z into dz by dx. Okay, similarly I can write du by dy, dou f by dou x dx by dy, dou f by dou y dy by dy, this is one anyway, dou f by dou z dz by dy, and lastly what is that, du by dz, I can write dou f by dou x into what is this, dx by dz plus dou f by dou y dy by dz plus dou f by dou z into dz by dz value 1. These are the total derivatives of a function. Now see, if let me write, see, all of you, these are explicit functions. If z equal to f, that means z is expressed in terms of x and y, u is expressed in terms of x, y, z, that means explicit functions. For example, composite function, let me define first this one. What is this composite function? What is the definition? If z equal to f of xy is function of x and y, and x y are functions of t. X and y are functions of t. That is what x equal to some, you write phi 1t function of t something, y equal to phi 2t some function of t. See, logic is what here I'm telling. Z is function of how many variables? Two variables. Z is function of two variables, right? Then x and y are functions of what? Single variable. See the logic. Z is function of two variables and x and y are functions of single variable. So automatically, if I substitute x and y here, f is function of what? T. Nothing but z is function of what? T. Then z is function of t. Then z is function of t. How many variables? Only one variable, and is called composite function of single variable. Composite function of single variable. Composite function of single variable. Now, what is here? Therefore, z is now what? Completely. If I put x and y in terms of t, z is function of single variable now, like y equal to f of x. When function of single variable, what is the derivative? Ordinary derivative. So dz by dt exists. Dz by dt exists. Now, let me explain clearly here. For example, z equal to something x square plus y square. And x equal to, I will take t, y equal to some t square I will take. Okay, right? Then what is that? Then z equal to how much? This is t square plus t power 4. That is function of t. Then I can calculate dz by dt. What is this? 2t plus 4t cube. This is called substitution method. This is called substitution method. Now, in this total derivative, we are not using substitution method. I have to write the formula. What is this here? Z is function of t. Now see the logic. First one, what is Z is function of what? Initially, Z is function of x, Z is function of y. So here I have to write dz by, since at last Z is function of t, there exists ordinary derivative of Z with respect to t. Ordinary derivative. That is why I have written dz by dt. Now coming to on the right side to write total derivative formula. First thing, what is z? Z is function of two variables. Since z is function of two variables, there must be a partial derivative. There must be partial derivative with respect to x first. With respect to x. Then what is x? X is function of t. X is function of t. Therefore, I can write this is x is how many function of how many variables? Only single variable. So I have to write dx and with respect to t, because I'm taking derivative with respect to t. Once again, z is function of x and y. X and y are functions of t. So z is function of t, single variable. So its derivative is what? Obviously ordinary derivative. That's why dz by dt I have written. Then how to write total derivative formula? Dz by dt equal to, first z is a function of two variables. Therefore, first z function of x, next function of y. I will write here also. Dou z by dou y. These are the partial derivatives because z is function of two variables. Now here x is there now. This x is function of what? I have written previously one formula to express this is, what is total differential? Dz equal to dou z by dou x into dx plus dou z by dou y into dy. I have written, right? Now derivative with respect to what? T. So dx by dt, and remember x is function of single variable. That is why ordinary derivative here also. Now dou z by dou y is also function of single variable. Therefore, I must write dy by dt. I must write dy by dt. This is called total derivative of composite function, single variable. Total derivative of composite function, single variable. Okay. Once again, z is function of two variables. So here partial derivatives, and x and y are functions of single variable. So ordinary derivatives. Now in a different manner. if z equal to f of xy is function of xy, function of x and y, and x, y are not function of single variable, function xy are function of you take some two different st or uv, better you take uv. X and y are function of u and v, two variables. What are x and y? Functions of uv. So let me picturize this. What is this? Z is function of two variables, and xy are also function of what? Two variables. So obviously what? Z is function of u and v. Z is function of u and v. Therefore, z is function of two variables, not single variable. What is this? Z is function of two variables u, v. Therefore, total derivatives are given by how many total derivatives? Given by z is function of, now previously total derivative only one, because z is function of t only. Now z is function of u and v. Therefore, there are two total derivatives. What are those? Z is now function of what? U and v. Z is function of u and v, function of more than one variable. Therefore, definitely partial derivative. Dou z by dou u, one. Another total derivative is what? Dou z by dou v, not d. Remember, z is function of now two variables. Therefore, dou z by dou u, dou z by dou v, dou z by dou v. Now, coming to same logic, I am giving z is first function of what? X and y. So, let me write dou z by dou x here plus dou z by dou y here. Next one, differential quotients what? X and y are functions of what? U and v. So x and y are functions of how many variables now? Two variables. Therefore, again partial derivative. Dou x by first derivative taken with respect to u. So dou x by dou u. And here also derivative taken, y derivative is with respect to u. So y derivative with respect to u. First one, same logic here also. First, that is function of two variables. So dou x by dou x plus dou x by dou y. Here, now derivative taken with respect to v. So here dou x by dou v, and here dou y by dou v. All are partial derivatives because z is function of two variables, as well as x and y are functions of two variables. These are total derivatives of composite. Now here z is function of two variables u and v, and called composite function of two variables. Composite function of two variables. Composite function of two variables. Okay, this is about composite functions and their total derivatives. Okay, now next one, total derivative of an implicit function. Derivative of an implicit function. Implicit function means what? The variables are interrelated. For example, let f of x comma y equal to c be an implicit function. Be an implicit function. What is the meaning here? Implicit function means y is function of x. Y is also function of x. Okay. Loosely speaking, if x and y are not separated, that function is called implicit function. Simply, okay, in a loose way. This is let f of xy equal to c be an implicit function. Okay. Now to define the derivative, what is this? Derivative of an implicit function. Differentiating, take this as 1. Differentiating 1 with respect to x. Now logic is here. What is f? F is function of how many variables? 2. So first dou f by dou x. Differentiation with respect to x, since function of two variables, f derivative with respect to x. F derivative with respect to x into Differentiation with respect to x now, dx by dx plus. Now, f derivative with respect to y. F derivative with respect to y, and we are taking derivative with respect to x. Y is function of x. So equal to constant derivative 0. Constant derivative 0. Is that clear? Any doubts? Once again, f is function of two variables. Therefore, first partial derivative and x derivative with respect to x, single variable. So dx by dx plus f derivative with respect to y, partial, and y is function of single variable. Therefore, y derivative with respect to x. We are taking derivative with respect to x. From this, what I'm getting, dx by dx value 1, dou f by dou x, dou f by dou y into dy by dx equal to 0. That is equal to, what is the expression for first derivative? Dy by dx equal to minus dou f by dou x by dou f by dou y. You have to remember this one. You have to remember this. What is this one? Slope of the curve for an implicit function, simply called. This is called slope. Slope of the tangent to the curve. Slope of the tangent to the curve. What is that curve? F of xy equal to c. Or first derivative, dy by dx. How to write? See, hint is I'm giving. Hint is what? How to write? If f of xy equal to c, then this dy by dx equal to, first f derivative with respect to x, partial, because function of 2. Next, divided by f derivative with respect to y, put minus sign. That's it. Put minus sign. If it is, this is phi of x comma y, phi of x comma y equals c, then what is dy by dx? Minus dou phi by dou x by dou phi by dou y. Dou phi by dou y. Okay. This is what, how to remember this dy by dx. Now, after dy by dx, let us calculate second derivative for an implicit function. Second derivative for an implicit function. What is that? Shall I tell? It's complicated. Okay, let me finish. What is the question saying? This is formula for second derivative. Formula for second derivative of an implicit function. Of an implicit function f of xy equal to c or 0. Whatever it is, c or 0, or formula for a function is, let me write, what is second derivative? D square y by dx square is equal to minus q square r 2pqs plus p square t whole by q. Here p stands for dou f by dou x. P stands for dou f by dou x. Okay, next. Q stands for dou f by dou y. R stands for, R is there? Yeah, R is there. Dou square f by dou x square. S stands for dou square f by dou x dou y. And T stands for dou square f by dou y square. These are the notations. Let us prove this. Okay, in this proof you will understand everything. Okay, all the concepts. That's why I'm telling this one. First one, for the implicit function, f of xy equal to 0, we have, what is dy by dx? Already I know, I told you how to remember. First, f derivative with respect to x by f derivative with respect to y minus sign. This is nothing but what? Minus dou f by dou x is nothing but what? P minus p by q. Okay. I will not substitute p and q right now. At last I will substitute. Because you may get confusion. Now, what I required? D square y by dx square is required. So, take this as 1. Differentiating 1 with respect to x again, with respect to x. Then d square y by dx square we will get, that is nothing but d by dx of what? dy by dx. d by dx of dy by dx. That is implies, okay, d square y by dx square is equal to d by dx of what? I'm taking minus outside, dou f by dou x by dou f by dou y. Correct? This is d by dx of this. Okay. Now, this is what u by v formula. This is u, this is u, this is u, and this is v. Okay, u by v formula. First one. Before going to this, let me write. Let me write in easy manner. If I write like that, if I let me write u by v formula, what? First v into, that is dou f by dou y into dou by dou x of what? Dou f by dou x. Dou by dou x of what? Dou f by dou x minus, now u into dou f by dou x into dou by dou x of what? Dou f by dou y whole by v square, that is dou f by dou y whole square. Dou f by dou y whole square. So what I'm getting here, this is equal to dou f by dou y, correct? That's one. And this is dou square f by dou x square minus dou f by dou x into, this is what? Dou square f by dou x dou y you will get. Dou x dou y whole by dou f by dou y whole square. Dou f by dou y whole square. Not like that. I need dou f by dou x. Here dou f by dou y. So yeah. See, if I write in this manner, it looks like it's correct, but it is wrong. It is wrong. This part is wrong. This part is wrong. How to write this? Let us see. Okay, let me keep like this only to get to understand the topic. Now you take, see, actually I should write the df by dx here. Let me write here. For f of x y equal to 0, okay, differentiate with respect to x. What I'm getting? First dou f by dou x into dx by dx, right, plus dou f by dou y into dy by dx equal to 0, right? Differentiating with respect to x, that is equal to dou f by dou x plus dou f by dou y into dy by dx equal to 0. Are you getting? Differentiating with respect to x means what? Dou by dou x of f. Dou by dou x of f equal to 0. Equal to 0. That implies, all of you keep this one in mind. F of xy equal to 0. Differentiating this one with respect to x means dou f by dou x. And what is this dou f by dou x? This dou f by dou x is what? Exactly this. Dou f by dou x is what? Exactly this. Got it? Just now we did here in first derivative. In first derivative, f of xy equal to this may be 0. Then what is differentiating with respect to x means what I'm getting? Dou f by dou x of this entire. This is the value of what? Dou f by dou x of x comma y. Since f is a function of xy, f is a function of xy. Now that is why this is the mistake. Here this is the mistake. Okay. Then how to write this is dou f by dou y as it is. Dou f by dou y as it is. Now dou by dou x of dou f by dou x is what? Dou by dou x of dou f by dou x is what? Using again chain rule, you can substitute like this. What is this? Dou by dou x of, what is this one? Dou f by dou x? Dou f by dou x plus dou f by dou y into dy by dx into dy by dx minus dou f by dou x. And what is this? Again dou by dou x is there, none, but it is dou f by dou y. It is dou f by dou y is there. So dou f by dou y, is there any, with respect to x only we are getting this. If I write with respect to y, this one with respect to y, dou f by dou y dx by dy. No, not like that. Confuse అవుతుంది కదా. Let us separate the terms. That's better. If I separate these terms, if I calculate individually, that's better. Wait. Not this double derivative. D by dx d square y, right? That's correct. It's a simple way, but I'm losing the concept, right? Dou by dou x. I can write this is again, since dou is there, it's not, it's a mistake. So I should write d. I should write d. So if I consider this as completely function of x, this is completely function of x. Yeah, dou f by dou y. So I should write this is, if I write d only, then this principle is applicable. This is d only, this principle is applicable, right? Done. Coming to dou f by dou y. Just 2 minutes. Double derivative. First derivative slope, right? D square y by dx square. Let me, before going to this, up to here, that's okay. This is also okay. This is also okay. Yeah. Now, d square y by dx square is equal to d square y by dx square equal to, by writing dou f, this is a problem. So if I express in terms of p and q, if I express in terms of p and q, this is d by dx of p by q, that is minus is here, minus p by q. Only the complicated exam. Let me try. Okay, this is actually dou f by d. Whenever d term is there, I have to replace that. D by dx of p by q. This is uv method. Q into this minus outside, dp by dx minus p into dq by dx by q square, by q square. Now let take this as equation 2. One is there now. Yeah, one is there. Equation 2. So I have to calculate dp by dx. Next dq by dx. dp by dx and dp by dx. That is nothing but d by dx of what? P value dou f by dou x. Dou f by dou x. Yeah, I got it now. The logic miss అయితే ఇగో ఇట్లాంటి ప్రాబ్లమ్స్ ఉంటాయి. Now see dp by dx, that means see this is ordinary derivative, this is ordinary derivative. So d by dx of dou f by dou x. Now exactly see this principle, this one, this is d by total differential df by dx. Df by dx means using total differential formula. First one, this dou f by dou x is function of two variables, therefore dou by dou x of dou f by dou x. చాలా జాగ్రత్త వినండి. పార్షియల్ డెరివేటివ్ వేర్ ఐఎమ్ టేకింగ్ పార్షియల్, వేర్ ఐఎమ్ టేకింగ్ ఆర్డినరీ, దట్ ఈస్ ఇంపార్టెంట్ ఇన్ దిస్ సెకండ్ డెరివేటివ్. ఓకే, ఫస్ట్ థింగ్ what just I will write to clarify, I will write this one, d by dx of some function of two variable, function of two variable. Okay, differentiating with respect to x. What I have written first, f is the function of two variables, therefore partial derivative of f with respect to x. Next dx by dx plus partial derivative of f with respect to y, then dy by y derivative with respect to x. This is the logic. Same logic in place of f, what is the term here? Dou f by dou x. That's it. Wherever f term is there, you replace that by dou f by dou x. So I'm doing that into dx by dx, into dx by dx plus this is what dou by dou y of what? Dou f by dou x into dy by dx, into dy by dx. Okay, now dou by dou x of dou f by dou x, this is now I can write directly dou square f by dou x square into 1 plus, into 1 plus I can write this is dou square f by dou x dou y, and what is dy by dx? I had already the formula. What is that? Minus dou f by dou x by dou f by dou y, dou f by dou y. Okay, so what is this one? Finally I'm getting dp by dx value. This implies dp by dx equal to dou square f by dou x square minus dou square f by dou x dou y into dou f by dou x by dou f by dou y, dou f by dou y. This is, take this as 3. Now dp by dx is over, this part is over, dp by dx. Next I have to calculate dq by dx. Now dq by dx equal to, again same chain rule, this is called chain rule. dq by dx equal to first what is d by dx of what is q? Dou f by dou y, dou f by dou y. Same logic. First dou by dou x of dou f by dou x into dx by dx plus dou by dou y of dou f by dou y, dou f by dou y into dy by dx, into dy by dx, right? So that is equal to, what is the first one? Dou square f by dou x dou y into 1 plus second one is what? Dou square f by dou y square, and what is dy by dx value? Minus dou f by dou x by dou f by dou y. Therefore what is dq by dx? Therefore dq by dx value is dou square f by dou x dou y minus, yeah, yes exactly, minus dou square f by dou y square dou f by dou x divided by dou f by dou y, divided by dou f by dou y. This is equation number what is this? 4. Equation number 4. Put 3 and 4 in equation 2. In equation 2, what is the 2 equation? Minus q dp by dx minus p dp by, okay, equation 2 implies, now 2 implies d square y by dx square equal to, minus is there, right? Minus is there. Q into what is dp by dx, first one. Dp by dx means what? This one. Dou f dou dp by dx is this one. Dou square f by dou x square. I'm putting in brackets. Dou square f by dou x square minus dou square f by dou x dou y, right? Dou square f by dou x dou y, dou f by dou x by dou f by dou y, dou f by dou x by dou f by dou y, dou f by dou y. This is next. I'm taking, okay, minus p into dq by dx. What is dq by dx? Exactly, it is here. Dou square f by dou x dou y, dou x dou y minus dou square f by dou y square multiplied by dou f by dou x by dou f by dou y. This flower bracket closed, and whole bracket is also there, that is also closed, and this whole by what? Q square. Whole by what? Q square. Now let me take LCM. Jartha chudandi ikkada. This step is important. I'm not cancelling dou f by dou y terms like that. Okay, here by taking LCM, what I'm getting, minus this Q. Q stands for what? Okay, let me write Q as it is. Q into dou square f by dou x square into dou f by dou y, by taking LCM, minus dou square f dou x dou y, dou f by dou x, correct? Dou f by dou x by dou f by dou y. Okay, minus here also p into, and this bracket is closed, flower bracket, LCM, dou square f by dou x dou y, this one, multiplied by dou f by dou y minus dou square f by dou y square into dou f by dou x, into dou f by dou x. This is one bracket, another bracket, flower bracket closed, and a whole bracket by what is this? Dou f by dou y taken LCM into Q square. Now last step, this is equal to see, let me write in terms of operators. Q, dou square f by dou x square means R, dou f by dou y means what? Q, dou square f by dou x dou y means what? Yes, dou f by dou x means what? P, minus p into, this is yes, dou f by dou y Q, dou square f by dou y square T, dou f by dou x P, this bracket closed, by this is Q into Q square, right? If I simplify this, minus as it is R Q square minus S P Q minus S P Q plus what is this? T P square whole by Q, right? So lastly, therefore d square y by dx square is equal to minus Q square R minus 2PQS minus plus P square T whole by QQ. Exactly the same expression we are getting. So where we are missed actually? In calculating double derivatives, write this, and see, this is ordinary derivative. Previously I have taken dou by dou x. That's why I have confusion. This is dp by dx. Whenever dp by dx is there, I have to apply this total derivative formula. Okay, practice this. Okay, for double derivative, you practice this and remember the formula, first derivative and the second derivative. Any doubts? I will stop here.